Hello and welcome to all the chemistry students of Mountain View High School. This is going to be a review of the subatomic particles practice quiz. Let's get started. I'm going to go a little bit fast, so feel free to use the pause button on your video player. Question number 1. The mass of an atom mostly comes from, well, if you remember from the notes, most of the mass is in the nucleus. Now there are electrons that also make up the atom, but electrons are much smaller and much less massive. In fact, by a factor of 10 to the negative 4. So basically, the mass of the electron is negligible when compared to protons and neutrons. So protons and neutrons are given a relative mass of 1 atomic mass unit, 1 AMU, and electrons basically have um, such a small mass that we give it an approximate atomic mass of 0. So to figure out the mass of an atom, you just need to look at the protons and neutrons. So that would be B. So anything with electrons, you can do a quick process of elimination, and then protons is not a complete answer. It is protons and neutrons. These are going to be where the bulk of the mass of an atom comes from. Correct answer is B. All right, question number 2. The atomic number of an element is equal to, well, if you remember from the notes, the identity of an element is determined by the number of protons, and that is where we get the atomic number from. So atomic number is really just equivalent to the number of protons. And if you were to see this in a nuclide symbol, that would be the number in the bottom left corner of the nuclide symbol. So don't get the nuclide symbol confused with what you see on the periodic table, because different periodic tables show it differently. But if you were looking at a nuclide symbol, it would be on the bottom left, and that is where you would find the atomic number, which tells us the number of protons. Again, atomic number is the number of protons. Okay, so the atomic number of an element is equal to, it's not the number of neutrons, it's not the number of protons minus the number of electrons. That would be how you calculate the charge. It is the number of protons, so that's right. And is it the number of protons plus the number of neutrons? No, that would be the mass number, so that's not right. Okay. So how many neutrons are there in an atom of hydrogen 3? So if you remember from the notes, isotopes of an atom isotopes of an atom are the same element, so they have the same number of protons, they just have different masses, so they have different neutrons. So we're dealing with an isotope of hydrogen in this example. So there's several different isotopes of hydrogen, but notice they all have 1 proton because they're all hydrogen. Hydrogens always have 1 proton. But when you're looking at isotopes of hydrogen, what's going to differ is the number of neutrons. So this hydrogen has no neutrons. So the only thing giving it mass is the 1 proton, so we call it hydrogen 1. Here we have a proton and a neutron. So there's basically 2 atomic mass units worth of mass in the nucleus. So we call it hydrogen 2. And here we have 2 neutrons plus that 1 proton, giving us hydrogen 3. So again, we're just looking at the mass number of hydrogen. So this was a fairly easy example, so we could just honestly count in our minds. But what if you're dealing with a heavier element that has a bunch of protons and a bunch of neutrons? You might need to calculate it doing the math way. So the math way, you would just use this formula. Mass number is equal to the number of protons plus the number of neutrons. So if you just subtract protons from both sides of the equation, you can get basically solve for the number of neutrons and get that the mass number minus the number of protons equals the number of neutrons. And I'll just rewrite it so that it's easier to visualize. And you can see this is just another way of rewriting this. And you should be able to solve for any one of these as long as you're given two of them. So you should be able to manipulate this formula and solve for whatever it is that's needed. In this case, we're calculating the number of neutrons. So we're dealing with hydrogen 3. So we're given the mass number, and we know that hydrogen has 1 proton. And you could have looked that up on a periodic table, but hopefully you know that by now. So number of neutrons is 3 minus 1, which gives us 2. So how many neutrons are there in an atom of hydrogen 3? There's 2. And again, I know that was an easy example, but I recommend the math way for more complex, for heavier elements. All right, question number 4. In order for an atom to be nitrogen, it must have what? Well, really, what gives nitrogen its identity? It's going to be the number of protons. So that sounds right. The mass, well, you can have different isotopes of nitrogen, so that doesn't sound right. 7 neutrons, again, that will affect the mass. So you can give, that'll give different isotopes of nitrogen, but that's not what makes nitrogen nitrogen. There's different elements that can also have 7 neutrons. But having an atomic number of 7, yes, that will make something nitrogen. So remember, the identity of an element is determined by the number of protons. That is what gives the atomic number. So 7 protons, yes. The mass, no. Is it having 7 neutrons? No. Is it having an atomic number of 7 that makes something nitrogen? Yes. So if you have 7 protons, you are nitrogen. And that is indeed what it says on the periodic table. And what we find in nature, of course. Question number 5, which of the following accurately summarizes the isotope argon-40? So this is an isotope of argon, and this particular form of argon has a mass number of 40. So that means the number of protons plus the number of neutrons should add up to 40. So going through this, 18 plus 22, that equals 40. 22 plus 18, that equals 40. 40 plus 18 does not equal 40, so that's not going to be right. Sorry, and then looking at this one, 39.95 plus 21.05, that does add up to 40, but you're not going to get a fraction of a proton or a fraction of a neutron, so that doesn't work. So I've already narrowed it down to basically A or B. So now we just need to figure out what is the correct number of protons and neutrons. What is the correct number of protons and neutrons? That will add up to 40, and that will be argon. Well, if you look up argon on a periodic table, you'll see that it has 18 protons. So we know it has 18 protons, and we're given the mass number. It's 40. So 40 equals 18 plus what? You just solve for the number of neutrons, and it is 22. So there should be 22 neutrons in argon-40, meaning the answer is A. You could have also just looked at argon-40 and seen that it doesn't say the charge, so you can assume it's neutral. So the number of protons and the number of electrons should be the same. So I guess in B, the number of protons and electrons was also the same, so that also would have had a neutral charge. But argon-40 should have 22 neutrons. That's how we figured that one out. Question number 6, fill in the table. So the name of this element is lead-209, so it's an isotope of lead, and we're given the mass number. So right off the bat, we should be able to figure out the mass number. All right, and we know that it is lead, that's given to us. So if you look up lead on a periodic table, you'll see that it has 82 protons. So we know the atomic number is 82 because the atomic number is just the number of protons. So the number of protons is 82. Now we just need to solve for the number of neutrons using the mass number equation. Mass number is just the number of protons plus the number of neutrons. So if we were to solve for the number of neutrons, we would just subtract the mass number take the mass number and subtract the number of protons, because this plus this should add up to the mass number. So 209 minus 82 gives us 127. So there should be 127 neutrons in lead 209. Right. That's a lot of neutrons compared to the number of protons, which is why lead is radioactive. Once you start trying to cram all these neutrons and protons into the nucleus, it can start to destabilize that nucleus. But anyway, we'll talk about more of that during the next couple of weeks when we talk about radioactivity. All right, question number 7, another fill in the table question. So let's see, we're given the number of protons. So that should be the same as the atomic number. So again, atomic number and number of protons are equivalent. And if we know the atomic number and number of protons, we should be able to look it up on a periodic table and see that this is the element bromine. So this is bromine. And now what is the mass number? Well, the mass number is just the number of protons plus the number of neutrons. So 35 plus 44 gives us 79. So the mass number is 79, making this particular isotope of bromine, bromine 79. Question number 8, a gold atom with 118 neutrons and a charge of +1 has how many electrons? So we want to know how many electrons there are. So what information is relevant? Well, the fact that it's a gold atom, that will tell us the number of protons, and knowing the charge is going to be helpful in figuring out the number of electrons. So the charge is just the number of protons minus the number of electrons. And we only need to consider the charged particles in this case. Neutrons have a neutral charge, so we don't need to consider them. We only need to look at the number of protons and subtract the number of electrons to figure out the charge. But the question we're looking at is asking for the number of electrons. So we would just use this equation and solve for the number of electrons. So let's take a look at this gold atom using that equation we just looked at from the notes. We're given the charge, which is +1. And how do we figure out the number of protons? Well, we're told it's a gold atom. So just look up gold on the periodic table, and you'll see that it has 79 protons. So just plug in the numbers and solve for the number of electrons. And we see that there should be 78 electrons in this gold atom, which has a charge of +1. Which makes sense, right? If you have 79 positive things and 78 negative things, you should have a net charge of 1 positive thing. So it has a net charge of +1. Question number 9. What is the identity and charge of an atom with 52 protons, 75 neutrons, and 54 electrons? Now the question is asking us for the identity and the charge of the atom. So if we want to know the identity, we can just look at the number of protons. And if we want to know the charge, we should look at the number of protons minus the number of electrons. So for identity and charge, in both of these cases, we don't really need to know the number of neutrons. So sometimes we give extra information, and you should be able to decipher what information is needed and what information is not needed. Okay. So looking up the number of protons on a periodic table, you'll see that the element with 52 protons, or the atomic number of 52, is tellurium. So to figure out the identity, you just look at the number of protons and look it up on a periodic table. Now, in terms of figuring out the charge, you just do the number of protons minus the number of electrons. Now, why did I already start eliminating this? Because we already figured out the identity, that's tellurium. So let's just go ahead and eliminate answer choice C and D, leaving us with A and B. So yeah, now we just need to figure out the charge. It's just the number of protons minus the number of electrons. So plugging in the numbers, 52 minus 54 equals -2. So the charge should be -2. Question number 10. An atom of uranium-238 differs from an atom of uranium-235 in which of the following ways? So these are just isotopes of each other. They're both uraniums. They should have the same number of protons, but they should differ in their atomic mass. Well, they differ in their atomic mass, meaning they must have different number of neutrons. So uranium has 238 has 3 more neutrons than uranium 235. That sounds right. Uranium 238 has 3 more protons. No, that wouldn't make sense. That would change the element. So that doesn't sound right. Uranium 238 has 3 more electrons than uranium 235. No, that doesn't sound right. That would change the charge, but that should not change the atomic mass, because again, the mass of electrons is negligible, so it should not affect the atomic mass. So that doesn't sound right. Uranium 238 has a larger diameter than uranium 235. That does not sound right. The number of electrons could affect the diameter and how many like orbitals they occupy, but it will not affect the atomic mass in a significant way. So like I said earlier, uranium is always going to have the same number of protons, 92. So we can eliminate that answer. That doesn't make any sense. And like I said, the electrons have a negligible mass, so that won't be enough to affect it. So the only thing that could affect the mass in this case would be the number of neutrons. And really, it's the number of neutrons that create isotopes of a particular element. In nature, we see that uranium-238 is the most commonly found form of uranium, but you can find some form. You can find uranium-235, though it is much more rare. Okay. Question number 11. How many electrons, neutrons, and protons would be found in an atom of carbon-14? So this is a particular isotope of carbon. Well, carbon is carbon, so it should always have 6 protons. You just look up carbon on the periodic table. So it should have 6 protons. Whoa, that doesn't say 6 protons. So you can eliminate that answer right off the bat. Well, what else can we look at? Well, we're told it's carbon-14, so we know the mass number is 14. So the number of protons plus the number of neutrons should add up to 14. So number of neutrons plus protons should add up to 14. That adds up to 14. Ooh, that does not add up to 14. So you can eliminate that. This does add up to 14. However, this is saying 8 electrons versus 6. It just says carbon-14. It doesn't say carbon-14 ion, so we can assume that this is a neutral atom, so it has a neutral charge. So the number of protons should add up to the number of protons should add up to the number of electrons. So the number of protons should be the same as the number of electrons. So that would have given it a negative charge, but it doesn't say carbon-14 ion, so A would be the best answer. Real quick, a fun fact about carbon-14. Although carbon-12 is the most abundant form of carbon on Earth, carbon-14 is used for dating old fossils because it's radioactive, and we can actually look at the rate of decay and look at the ratio of carbon-14 relative to other forms of carbon and use that to estimate how old fossils are. So if you ever hear those stories about like, oh, they just discovered these fossils are like 20 million years old, and if you ever wondered, how did they do that? Carbon-14 is used for dating those types of things. All right, the smallest particle of an element that retains the properties of that element is called, let's see the choices: an atom, nucleus, molecule, an electron. Well, that sounds like an atom to me. So atoms are the smallest particles of an element that retain their properties. Once you start bonding them together and once they start forming molecules, their properties change. So an oxygen atom by itself is going to have different properties than oxygen when it is bound with two hydrogens in the form of water, right? Because there's oxygen in water, but water has much different properties than oxygen by itself. And yeah, so the answer would be atoms. Now there are things that are smaller than the atom. So we have our subatomic particles. But at that point, once you get into the subatomic realm, they start to lose their unique properties of that particular element. So the correct answer is A, atom. All right, question 13. This was a fill in the blank question. A proton has a mass and charge of what? Electron has mass and charge of what? Neutron has mass and charge of what? So it's basically a question asking about the mass and charge of the different subatomic particles. So if you remember looking at the notes, we see that electrons have basically a negligible mass. They have basically a negligible mass. And then protons and neutrons both have a relative mass of 1 atomic unit. And then in terms of charge, electrons are negatively charged, protons are positively charged, and neutrons have a neutral charge, so no charge. So yeah, this is something that you should commit to memory, that electrons are negative, protons are positive, neutrons are neutral, and that protons and neutrons have a mass of 1 AMU, and that the mass of an electron is more or less negligible. So a proton has a mass of 1 AMU and a charge of +1. Electron has a mass of basically 0 AMUs and a charge of -1. And neutrons have a mass of 1 AMU and a neutral charge, so 0. Question 14, fill in the blank. By definition, the atomic number is the number of, well, if you remember, the identity of an element is determined by the number of protons. So it's determined by the number of protons. In order for an atom to be neutral, the number of protons must be equal to the number of what? Well, being neutral is referring to its charge. So to have a neutral charge of 0, the number of protons and the number of electrons need to be equal to each other so that they cancel out, giving us a charge of 0. So the number of protons must be equal to the number of electrons. All right, the blank of an atom is determined by adding together the protons and neutrons. Well, protons and neutrons are what give an atom its mass. So basically, it's referring to the mass number. Protons plus neutrons give us the mass number. And finally, isotopes of an element have different mass numbers because of the differing number of what? Well, if you remember that picture of carbon-14, they're all carbon, so they're all going to have 6 protons. So they're all carbon. What makes them isotopes of each other is the fact that they have different numbers of neutrons. That's what gives them a different mass number. So isotopes of an element have different mass numbers because of the differing number of neutrons. And last question, which of the following pairs of atoms are isotopes of each other? So we just said that isotopes of each other should have the same number of protons. The only thing that's different is the number of neutrons. But they're all going to have the same number of protons, meaning they should be the same element. So argon and calcium are not the same elements. That's not right. An element with 7 protons and 7 neutrons and an element with 6 protons and 7 neutrons. No, you just change the number of protons. That's going to result in different elements. That's not right. Here we have silver and palladium. Those are different elements. So they can't be isotopes of each other. So D is going to be our correct answer. Calcium-40, an element which has 20 protons and a mass number of 41. So if you look at your periodic table and you see what element has 20 protons or an atomic number of 20, you'll see that it's calcium. So whether it's calcium-40 or calcium-41, in both cases, they're still calcium. The only thing that's different is the number of neutrons, which is why these are isotopes of each other. There was a typo on your quiz where it said mass number of 40, which means they would have been basically the same isotopes of each other. So that was a typo. It should have been the mass number should have been different. I think on the quiz it was left as 40. So hopefully that didn't confuse you. But yeah, if you have different mass number but the same number of protons, those are going to be isotopes of each other. So I hope you found this review helpful. If you didn't do so great on the practice quiz, no worries, just go back and study. And if you didn't do so great on the Unit 2 quiz number 1 from last week, then I recommend you also go back and restudy for that, because we're going to be offering retakes during office hours this Friday. So yeah, take advantage of that opportunity. So again, I hope you found this helpful, and take care.